As a scientist, I have to build the puzzle pieces that I need to build this history of the universe. CanadaFrance Telescope is multifunctional. We need to think about solutions to improve the instrument, to make things work. One of the most impressive discoveries that we made here is an object that came through the solar system, and we were able to catch it. So we're trying to predict the evolution of the universe for the future.
Welcome to the launch of SOLIDWORKS 2019. We're going to be live with you here all day on both YouTube and Facebook. We're going to be showing you lots of great features that you're going to be able to learn about today, including performance, modeling details. We'll discuss smart manufacturing, design to manufacture, and some really cool innovative things this morning. Then stay tuned, and later on today, we're going to be discussing mesh to manufacturing, extended reality, and connecting the disconnected. To get things started, you guys saw a great video this morning, and I have a special guest from the CanadaFrance Hawaii Telescope, Greg Green. Greg, welcome.
Thanks, Jeremy.
Greg, tell us a little bit about what you do with what we just saw.
Yeah, so at CanadaFrance Hawaii Telescope, I'm the instrument designer and machinist. So my job is actually to use the software, SOLIDWORKS, to come up with innovative designs to either fix a problem or repair an existing broken component.
And that's because you're not just working on a new design, you guys are working with a legacy design that's constantly evolving, correct?
Yeah, we're 40 years old up there. Next year we'll be 40 years old. So it's approaching the end of life of this installation. So our next big goal is to actually just cut the top of the telescope off and transform from CanadaFrance Hawaii Telescope to Mauna Kea Spectrographic Explorer.
Can I just call that MSE?
Let's call it MSE.
All right, that sounds good. That sounds like a huge undertaking that you're going to be going through. Now, what we saw is actually some of the future ideas that you guys are looking at. Is that correct?
Yeah, exactly. So the model I provided you guys is actually MSE in its very early stages. It hasn't been detailed out yet.
Okay. So did you model all those individual components yourself?
No, actually, in-kind contribution from other governments actually has provided the dome and actually the telescope structure. So it's my job to take those sub-assemblies and actually bring them in together and look for conflicts or collisions and make sure the thing is going to work together.
So you're working with the legacy design as well as bringing together all these different ideas, and SOLIDWORKS is kind of the conduit or the natural language that you're using to bring everything together.
Exactly. We chose SOLIDWORKS because it is the universal language, seems to be most often. And even if our partners submit a step file or some other neutral file, we can import that easily.
Oh, that's great. So it's the CanadaFrance Hawaii Telescope. Tell us a little bit about where you're located.
Yeah. We're on the Big Island, and our headquarters is at 2,700 feet in Waimea, and our observatory sits on top of the mountain of Mauna Kea at 14,000 feet.
There's a little bit of a difference there. Any challenges you guys face?
Well, the lack of oxygen at 14,000 feet, yeah. 40% less oxygen, so we try and do all of our heavy thought processes down at the headquarters.
So these changes you guys are going to go through, this is going to be pretty drastic for the scientific community with what you're doing. You're making some pretty drastic changes. I think you talked about some numbers.
Yeah, it's the first time that a facility like this will be repurposed, a remodel project. So we're trying, the goal is not to use a new piece of land up there, which is very valuable, and just use the existing facility and go from a 3.6 meter telescope up to a 10 meter class telescope.
So that's a massive change that you guys are implementing.
Massive change. Luckily, our facility was designed back in the 70s when steel was cheap, so the existing building can support the load of a larger telescope and a larger dome.
And SOLIDWORKS kind of helps you understand how those changes are going to take place.
Exactly. We modeled all the facility structure and then submitted that to a engineering corporation that determined for us that it will support the load.
That's great. So we're here today talking about SOLIDWORKS 2019, and you got an opportunity to take a sneak peek at this. What are some of the things that were really exciting for you?
Yeah, well, our model's large, and it's only going to get larger. It's a huge model, and the performance increase in the graphic capability is amazing. I mean, the way it loads up so fast, probably 20 seconds it seems to load up, whereas I was probably 2 minutes before.
Wow.
So that increase in performance is amazing, and we were also just awestruck at the virtual reality, or the extended reality.
Yeah, you had a chance yesterday to put the headset on and actually go inside of this design before any work has been done on the new design, right?
It's amazing. It's absolutely amazing.
Greg, this is a great story, and people are going to be getting an opportunity to see the CanadaFrance Telescope throughout the rest of the day as we show some great new capabilities. Greg, thanks for being with us here today. We'll see you later. We're going to be bringing on some folks now to continue talking about the actual features that are coming in SOLIDWORKS 2019. And one of the things Greg mentioned was performance. So to talk about performance, I have Mark from Product Introduction and Sid from Product Development. Welcome, guys.
Thanks, Jeremy.
Thanks.
Glad to have you here. Sid, why don't you tell us a little bit about what you do in product development for SOLIDWORKS?
So I'm a senior dev manager for the SOLIDWORKS graphics team. Part of my role deals with looking at the current graphics industry trends, research, prototype, bring up solutions for our customers in the realm of graphics quality and performance.
Okay, so Mark, you've had an opportunity to kind of look at some of the stuff that Sid has worked on.
Sid's been working diligently for a while to try to make sure that this stuff is really fast. And one of the things that they've worked on for 2019 is graphic performance. So when you have these massive models like Greg talked about, you want to be able to interact with them and work with them and kind of zoom around. So if we look at SOLIDWORKS 2019 here, and we look at Greg's model, the entire telescope, there's about 7,500 parts in here. And you can see as I grab this and just move it around on the screen, it actually feels like it's a simple block on the screen. So you can zoom, pan, rotate, rapid, very fast. It feels, I think it's a feel. It's one of those things that it's a feel. If we take a comparison and try to compare what it was like in SOLIDWORKS 2018 compared to what it's like in 2019, 18 on the left, 19 on the right, and you can see that kind of chunkiness as the mouse has to catch up. Sid can talk better about this, but it's what from development point of view, they call dropped frames. We have to drop those frames in order to get the model to rotate. In 2019, there's none of those. They're dramatically reduced, all those drop frames. It just feels so much better to interact with your model, zoom in, get to where you want to go, and visualize things so much better. You're still going to work with your assemblies. It's just, like I said, it's going to feel better. I think Sid describes it as it's an emotional thing, and it really is. It just feels like, wow, this feels like I'm rotating a block around on the screen.
So to leverage this, do I have to turn on a special mode or anything like that?
That's a great question. So what we're doing is this new graphics stuff that Sid has worked on is we've pushed a lot of the work that we did, more of the work, up onto the graphics card. So instead of it being on the CPU or on the main chip, it's now getting pushed up onto the GPU or the graphics card. We've done a lot of things in the past with large assembly mode to make an assembly perform and interact with a lot better in large design review in these different modes that we have. And we did that, but when you did that, you lost your real view, you lost your edges, you lost your shadows, and a lot of the visual appeal. And with the new stuff, you can do this. You have your full real view, full shadows, reflections, ambient occlusion, things like that are available in any mode, large assembly mode, part mode, large assembly mode, fully resolved, lightweight, LDR. You know, it really doesn't matter.
And we're going to see this in other places in the software too, right?
Right. Sid can talk about that.
Yeah, Sid, this is pretty groundbreaking. I have to imagine some really interesting technology or thought went into this.
That's right. One of the things is that our customers are really passionate. They're amazing. They spend a lot of time building huge data sets, putting materials, a large number of materials to make it look good, to make the data sets look good. And when you have to deal with millions of polygons, with hundreds of materials, it comes quite a challenge of how do we make this as performant as possible for our customers. And so we took a step back and we changed our design and programming paradigms. And now we have all of these data sets that's all transferred to the GPU, onto the graphics card. So you're no longer bottlenecked by the CPU, but it's more focus put on the GPU. And we came up with a bunch of algorithms that directly work with the dataset on the GPU. The advantage for this is that now everything is done on the GPU. Your performance scales across different generations and models of graphics card. And not only that, but we also kept the bar for performance really high. In the couple of next sessions, we'll be talking about VR. And we kept our performance such that we need to support VR, and our performance should match up to those expectations. We also worked with a large number of graphics vendors, and so we make use of specific extensions by these graphics cards. So we going the whole 9 yards, we're focusing on performance very diligently.
So the investment I've made in that graphics card, instead of having a diminishing return, it's just going to continue to drive in and take full advantage of that capability.
That's right.
That's really exciting, and I'm sure users like Greg are going to be really excited for this. One of the things we've done this morning is we've launched the What's New section on the SolidWorks website, and there's going to be tons of videos showing even more than what we can cover today. If there was something you wanted the users out there to go check out and watch, what are some other things that you find interesting?
I think I suggest the audience look at the 3D texturing and as well as the VR support in eDrawings. Both of these came directly from the graphics team, and I think they're really neat features.
Well, we're going to be taking a look at those later. Sid, thanks for joining us today. That's really exciting, discussing performance. But what we really want to look at are some of the tools that our users benefit from every single day. And this really comes down to feature, functionality type stuff. So for that, we've brought Marlon from the product definition team out with us. Marlon, thanks for joining us.
Thank you for having me.
Marlon, we just talked to Sid from product development. Tell us what product definition does and kind of what your role is at SolidWorks.
So the product definition team, we're embedded with development. I work very closely with Sid. I worked with him on the graphics project. We're embedded with development, and we are the user advocates in the development process. And to inform that advocacy, we spend about 1/5 of our year doing customer research. We do a lot of customer visits, a lot of work reviewing user enhancement requests, going through a lot of our databases of user-generated information about SolidWorks. And that's part of our research initiative, and we use that research to develop a project list for the next release and for future releases. And then the other 4/5 of the year, we're working very closely with development and quality assurance to implement that project plan by developing concept design, reviewing those concepts with users, developing detailed specifications, and then on the back end, alpha and beta testing our new functionality.
Yeah, you're always working with customers. I always see that. Sometimes I'll try to get a hold of you, and you're at a customer, it seems like. So you've worked on some really interesting stuff in this release. What's one of your highlights or one of the favorite things you've been working on with SolidWorks 2019?
So I really like in this concept of working with mesh geometry, I really like our 3D textures, and I know you asked for one, but I'll throw in slicing as well.
Sure.
That was another good project in that area.
So Mark, I know you've had an opportunity to look at the software. Can you tell us a little bit about both of these?
So Marlon mentioned the mesh modeling, and a lot of people are adopting mesh modeling, whether they're getting information from scanned models or artistic type of stuff. So this model that we have on the screen here is kind of a handle. It's an organic shape. In this case here, this actually originated from a 3D scan model. So we're just opening a 3MF file. You can clearly see that this is a mesh model. You can see all the mesh edges and stuff that are on there. But what people want to do is take this scan model and actually turn it into an engineering model that they can shell it and add ribs and standoffs and all the internal stuff that they want to be able to do with it. So we added this new slicing tool. You choose a plane, you choose your offset, you choose, and SolidWorks creates a folder full of planes and offset sketches that are fully editable. So you can kind of set these up to start using these sketches to build your model. We'll turn off the mesh body that we have in there and just use standard SolidWorks modeling techniques, leveraging that mesh information, and then just grab these curves that were created, and there you have it. We have a surface already started to start building our model. So that's kind of one of the cool things. As Marlon mentioned and Sid mentioned as well, the 3D texturing stuff. If you have a model like this grip inset here, it's a little blue part here, you can see that maybe we want to experiment with various different grip patterns that are on there, but you can see that's a lot of features there. There's 14 or 16 features to do that. The new 3D texturing allows you to do this rapidly. So instead of having to model those dimples or bumps or even something like this, this logo here, we've given a new methodology for doing this. So you're familiar with applying textures or appearances. I'm just going to drag one of these from the task manager onto the model. Standard ways of applying materials that you've been familiar with in the past. In this case here, we kind of have a neural pattern, change the size, change the rotation. So all I've done is apply them an appearance. Now we have this 3D texturing tool that leverages that appearance and allows me to turn that into mesh geometry. So I have controls over the mesh size. I can change the height at which I want that to pull out. The lighter colors pull farther out of the material and the dark colors stay back. So what I've done is use this new tool to create a mesh model. This mesh model can then be used downstream for manufacturing. So maybe I'm just building prototypes. I might want to create a 3D print of that. So that's a mesh model. 3D printers accept mesh models. That's their basis of how they build stuff. So that's kind of a cool way to leverage this whole mesh modeling methodology to take it from start to finish.
Yeah, I mean, that was a huge time saver. Thinking about having to create all those details as features
Well, there were 16 features just for those horizontal ribs, which are a little bit easier to do. Trying to create that neural in there, or all those dimples, or all those bumps, that's difficult.
We're really doing a lot of stuff with mesh as a kind of a geometry type inside of SOLIDWORKS, and we're going to be discussing this a little bit more later on today. Now, Marlon, that was a big feature. That's like new technology, new feature. But you also look at improving existing features and workflows, right?
Yeah, from all the feedback that we gather, we see new capabilities that we need to implement in SOLIDWORKS, but also we look for opportunities where we can make the user's workflow more efficient, where they can currently, in the end, they can do the same thing now that they could do in a previous release, but we work to make it more efficient, so that their experience is more enjoyable and a lot faster in SOLIDWORKS. And ultimately, the goal is to save time. And we call these projects, we have an internal name for them, we call them Delighters. Yeah.
Any delighters that stand out in your mind that are going to be really great this release?
So I really like partial edge chamfer, and then also we've made some improvements to projected curve, to make geometry that you could create in the past, but now it's a lot more efficient in SOLIDWORKS 2019.
All right, you want to run us through this, Mark?
Absolutely. So in this case here, we have this our handle that we kind of got started with, and you can see there's two surface bodies in here. So in the past, we could only project in one direction onto a single surface body. And we could also only do a single closed profile or open profile to get that projection on. Now in SOLIDWORKS 2019, multiple closed or open profiles can be projected onto multiple surfaces and bidirectional. In this case here, we're going to choose the bidirectional option, and it puts it onto both surfaces. Jeremy, in the past, this would have taken 2 sketches for the 2 closed profiles and then 4 features to project it onto each side. So we've gone from a single sketch with a single projected curve, or we've gone to a single sketch to a single projected curve from 2 sketches, 4 projected curves. So like Martin said, a lot of big time saver there.
So not only is it easier workflow, it's less features in the tree.
Less steps, less features in the tree, yeah, absolutely. And everything's stored then in that single feature. The other thing that's interesting is the partial chamfer. You can see I did a little quick interference detection. I have an interference problem. So I'm going to need to knock that corner off of this model. So I'll edit that part, choose the edge, chamfer it. But I really don't want to chamfer that whole thing all the way around. So we've introduced a new partial chamfer tool. In this case here, I'll just choose, I have various options for how I want to control the distance, or just use the drag handles that are right on the screen there, drag those. These can be symmetric or asymmetric. And by the way, this is a chamfer, but this can be done for fillets as well. And I can switch back and forth, as we've had in the past, switch back and forth between chamfer and fillet. So again, we could have modeled these things in the past. It's just there's a lot of extra time, steps that you're going in to model that to make that, to achieve that same goal.
Greatly simplifies that process of defining that.
Yep.
So these are some really cool features, and there's a ton of new features also on the What's New section of the SolidWorks website where you're going to be able to see. We're just showing some of the real highlights here today. But Marlon, you were mentioning you get an opportunity to talk with customers a lot. We have SolidWorks World coming up here in the near future. You're always busy at SolidWorks World, right?
Yeah.
Tell us about that.
Yeah,
How customers can engage with you at SolidWorks World.
For us in product definition, it's it's like drinking from a fire hose, SolidWorks World, because for us it's a 5-day event. It starts on Saturday when officially the conference starts Sunday evening. And on Saturday, we're doing alpha testing with customers. All day Sunday, we're meeting with customers all throughout the event. In fact, we take a break to give our presentations during the conference. And again, the entire goal is to learn more about the user's experience using our software, what enhancement ideas they have, what things we can implement in the future. And when you register for SolidWorks World, which you can do today, right?
Yep.
There is an option when you register to say that you would like to participate in our research activities. If you check off that option, that's how you get invited to the Saturday and Sunday events.
That's great. So if you're interested in working with someone like Marlon to have a good influence on the next release of software, go to SolidWorks World and sign up and be a part of that. Yep. Marlon, thank you so much for being here. Mark, thanks for being here talking about these new features.
Thank you.
One of the other things going on this week is really exciting. We're at, SolidWorks has been at IMTS in Chicago, Illinois this week. We've got some really cool new technology coming as it relates to smart manufacturing. So we're going to turn it over to Barb, who's actually over there.
Hi, we're in Chicago for IMTS 2018. It's the largest manufacturing technology show in the Northern Hemisphere. We're here with over 115,000 attendees, 2,400 exhibitors showing the latest in manufacturing technology, both on the hardware side and the software side. So what do you say we go and see if we can find the SolidWorks team so we can find out what is the latest and greatest in SolidWorks 2019 that's going to deliver smart manufacturing technology for all our users. All right, hey, we're here at IMTS. We've caught up with Mike Buckley.
Hi, my name is Mike Buckley. I'm a product manager for SolidWorks, and I'm in charge of SolidWorks CAM and our subtractive manufacturing. One of the reasons I'm into manufacturing is I love building and restoring old cars.
So Mike, we're here at IMTS. SolidWorks is everywhere at this show, but SolidWorks CAD, everyone knows that. SolidWorks CAM, that's pretty new.
So first thing everyone needs to know is SolidWorks CAM Standard comes with every seat of SolidWorks. Starting with SolidWorks 2018, we actually released SolidWorks CAM Standard and SolidWorks CAM Professional. Okay. CAM Standard is available to anyone on subscription, so every seat of SolidWorks has that. Allows you to do basic part machining. And then SolidWorks CAM Pro is actually for people that want to be more productive. So we've added things like assemblies, turning, volume mill for high-speed machining, those components. Okay. So it's a pretty exciting time to use SolidWorks and CAM together.
So SolidWorks CAM 2019, like what are our customers going to be most excited about in terms of new enhancements?
So there's some really cool things we have coming in 2019. The first thing is tolerance-based machining for turn parts. So we can apply the MBD data automatically to the toolpaths that we create with inside of SolidWorks CAM. So it's going to really speed up that process and create a profile or a program that we want that's going to be right the first time. The second thing that we're doing, which is I'm really excited about as a mill person, is for volume mill, we're actually adding rest machining, so I can come back and clean up the pockets with smaller tools and maintain tool life. Which is pretty important for some of us that have to buy our own tools. Sure. The second part is we can do zigzag on high-speed machining. So if I'm cutting a really long part, I can remove more material faster. And then one of the things that is going to be really good for our customers that have lots of different types of machines is I can do machine-specific rules in SolidWorks 2019. So if I have a mill and a lathe and a water jet, I can apply specific rules for each one of those machines automatically. So it's going to be really cool for our customers to be able to automate that process from start to finish.
First thing you mentioned was tolerance-based machining for turning. What exactly does that mean?
Yeah, so it's a really good question because we get a lot of those questions as they come in and we start talking about tolerance-based machining. So the first part is we actually use the dimensions that were applied in the 3D model. So we're using that MBD data that was created. We know what the engineer wants for specifications, and then we go through and we read these tolerances on the part and automatically apply toolpaths. So we're taking what the engineer and designer wanted and what their thought process was, and we're just auto leveraging that for the machining strategy. So we're making sure we make everything in tolerance correctly the first time.
Wow, that sounds like smart manufacturing.
Yeah, it is. That's one of the greatest, coolest things we have today is being able to leverage that one file to capture all of the design and manufacturing intent.
Now, does that extend further downstream into quality and inspection?
Yeah, absolutely. So the great thing about MBD is it sort of creates that container with all the data sets in. So if we go through and we apply inspections, say, to this part, we can auto balloon all of these. So as we machine it, we know we're creating those tolerances correct. But then from the inspection side, we have the automatic inspection report that's created from SOLIDWORKS inspection. So people are keeping that consistency together. And the cool part is if the design changes or if a revision happens, all of that information updates automatically on the fly. There's no need to go to separate sources to actually update and track that information. So it's a pretty cool process.
Users on subscription obviously get CAM for free, which is awesome. And all these capabilities sound really exciting. But what about just the machinists who basically just need to open part assembly files?
Yeah, so that's a really good question. So starting with 2019, we've actually created two bundles, a Machinist Standard and a Machinist Professional. Machinist Standard actually allows a machinist or programmer to be able to open up a SOLIDWORKS part file or import any customer's file and do programming on a part. And then Machinist Professional allows you to open up parts or assemblies or design fixtures, just doing parts and assemblies and then using SOLIDWORKS CAM Professional. So for the people that may not need all of that capability in SOLIDWORKS, we now have these packages that allow them to access all the cool things within SOLIDWORKS and all the great modeling capability we have, but still be able to put any of the high-end toolpaths on it that we may need. So it's a pretty cool, exciting time for people that are machinists to be able to get access to best-in-class tools.
What does smart manufacturing really mean to our users?
Yeah, so the basic understanding of smart manufacturing is from start to finish, you have one file or one truth where all of your data is stored. So when you do concept, you do simulation, you do FEA, all of that information gets stored in the file, right? So when we start talking about the manufacturing side of it, we're talking about capturing inspection, we're talking about capturing PMI data, and then we're talking about leveraging that for CAM. So the ecosystem within SOLIDWORKS allows you to have that one part or one assembly as one file to rule them all. You have the ability to store all that information in. So if there is a revision, there is a change, or people have questions, you just go to that one location and that is the truth of what's being built. A lot of systems today that aren't smart manufacturing, you have to export or import or do all this different files. And then what you end up with is if there's a problem, you may not know where the problem resides. By having all of that in one file, we can tell where the problem is going to exist if there is one.
Wow, it sounds like SOLIDWORKS is all over CAM and there's so many exciting things happening this year. So is there anything else happening in manufacturing with SOLIDWORKS that we should know about?
Yeah, so one of the great things we're doing for our students this year is starting with SOLIDWORKS 2018 in education, which came out this fall, is all seats of SOLIDWORKS education get SOLIDWORKS CAM Professional. So every student has access to MBD, tolerance-based machining, volume mill, all of the great things that we've talked about. They're all going to have access to that starting today. So it's a pretty cool, exciting time for students to get in and build products. So if you want to learn a little bit more about SOLIDWORKS CAM, you can actually go to My SOLIDWORKS. Another benefit of being on subscription, you can log into My SOLIDWORKS and we have 18 videos up there that go over the basics of SOLIDWORKS CAM Standard. So that's always a good place to go and start and learn a little bit more about our products and what we have to offer.
So we just talked to Mike, we heard about all the cool new enhancements in SOLIDWORKS CAM 2019. We talked about milling, we talked about turning, we talked about tolerance-based machining, and of course it all starts with model-based definition, but even downstream to inspection and quality. SOLIDWORKS CAM 2019 provides all the puzzle pieces for your smart manufacturing initiatives. And don't forget, if you're a SOLIDWORKS CAD user on subscription, you already have SOLIDWORKS CAM Standard available to you. So let's get started, folks. We can't wait to see what you build.
Barb and Mike, that was really exciting news about what we're doing with smart manufacturing and SOLIDWORKS. I'm joined back here in the studio, though, with Kurt from Product Introduction and Craig from the Product Management team at SOLIDWORKS to actually talk about design for manufacturing. Welcome, guys.
Yeah, thanks, Jeremy.
Craig, we've had a few folks on this morning from different aspects of the SOLIDWORKS organization. Why don't you tell us a little bit about what product management does and what you do?
Yeah, so I like to think of product management is in charge of the process, right? The whole process from design through manufacturing and even selling the product with SOLIDWORKS Sell and configuring and having these augmented reality and virtual reality experience. So how do all the pieces work together? That's the key thing, and making sure that everything works together.
So talking about, that was really great what Mike had shared with us talking about smart manufacturing. You spent a lot of time at SOLIDWORKS talking about design for manufacturing. Tell us some of the things in SOLIDWORKS 2019 that really catch your eye.
Yeah, well, right off the top, what we're doing in sheet metal, all right? So sheet metal is one of those areas where Is it design or is it manufacturing, right? Because you do design work and then you flatten the parts. And now in 2018, we added the tab and slot feature. So tab and slot was something that came out from our investigation of design and going to the shop into manufacturing. And we noticed that on the shop floor, people were self-fixturing their parts, their sheet metal parts, and then welding them. Rather than having to build fixtures, you can self-fixture with these tab and slot features. Those features were sometimes being put on after the design was done. It was being done in the laser tool paths, things like that. So we said, why don't we allow designers to put it in ahead of time, and they can add that information so by the time it gets to manufacturing, it's already there.
And so as a result of this, we had overwhelming response, and they wanted more from this, right?
Yeah.
I think, Kurt, you were going to show us some of the new things we're doing with tab and slot as a result of this customer feedback.
Yeah, Jeremy, like Craig said, we introduced this in the 2018 version and just had overwhelming feedback and added a lot of extended functionality here in 2019. So the very first one that you see is in 2018, your tab was always centered in your slot. Now you can offset it, just a simple tab, but it makes it very easy for users. As we move forward, last year we had just a square corner, but in 2019 we've added round corners, like you see, chamfered corners, and even dog bone or circular corners in the edges. And again, this is critical when you make your flat pattern for the laser cutter and for downstream manufacturing operations. So last up, this one's actually really neat. If you don't want to have a hole in your part where the slot goes, you can actually leave that out by not cutting it all the way through. So it helps make your design even more watertight if that needs to be the case.
So I have to imagine these ideas and these features from customers came from their, literally like you were saying, they want to go right to the laser with this, and these are some great features. Now, we talk about designing for manufacturing. Sometimes design has to communicate with manufacturing as well, and you were talking about some interesting experiences you've had there as well.
Yeah. So on the shop floor, I mean, really the shop floor has gone digital, right? When you go down to the shop floor, you used to see stacks of paper, of drawings, 2D drawings that were paper. What you're seeing now are large flat screen monitors on the shop floor. So people are sometimes they're looking at a 2D drawing on that, but a lot of times they're looking at 3D models, and they're able to interrogate the models, modify them even on the shop floor. So it's really changing the shop floor by having these electronic capabilities, monitors, PCs on the shop floor, and you're able to actually get directly to the 3D models more conveniently.
And we've always had a really great tool for this that we're doing some stuff with in 2019. You want to tell us about that?
Yeah, a couple of tools and obviously our big one, e-drawings.
Yeah.
So in e-drawings, we've added the ability now to open more file types, so STEP, IGES, and also native CAD file types, other CAD file types. We've also added the ability to natively open configurations from SolidWorks files, from PRTs and ASM files. And then lastly, and most importantly, I think big thing, is we can save as web HTML. So I can open that file and not have to do any kind of a download at all. And I can just open it in a web browser.
So I don't have to send you an e-drawings file, or I don't have to install e-drawings. Nope. Anybody on any device pretty much can open an HTML file, right?
Right, exactly, anybody.
That's great, and I think a lot of users know e-drawings is a great tool for sharing a 3D model with somebody, but sometimes it's more than just sharing a model. Sometimes it's taking the data from the model and going further and communicating design ideas or downstream applications. Kurt, you have a lot of experience with this.
Yeah, a lot of companies say we don't get paid until the final technical documentation goes to the end user. So we're talking like assembly instructions, user manuals, maintenance manuals, all of that stuff can be brought in, concurrent in the design process with SolidWorks Composer. And Composer's seen a lot of new enhancements in 2019 as a communication tool for making all of this type of technical communication. In fact, one of the things that Greg's going to be using it for is to share their ideas and share everything about what the new telescope looks like, up on to their stakeholders and their funders. So all of that information is right there for the user in one simple spot, fully created and fully associative to the SOLIDWORKS model.
Kurt, that's really exciting. You know, what they're going to be needing to do with MSE, share their ideas, they're really needing to show how they're going to innovate, and they're creating an experience, kind of how this telescope is going to come together. But that's something we're always focused on here at SOLIDWORKS as well. And that brings me to my next guest, Kevin, with User Experience, who's actually involved in that. Kevin, thanks for joining us.
Yeah, great to be here. Thanks, Jeremy.
Kevin, why don't you tell us a little bit about, we've talked with folks from product development, product definition, product managers. You're in user experience, which is a little bit different. Explain to us what your group does.
Sure. I mean, ultimately, we're responsible for the user interface of SOLIDWORKS. So everything from what the workflow is, how the user interface looks, to how users interact with it. We gather their feedback, put it back in, and make sure that things are efficient and easy to use.
Now, I think a lot of times users, when they think user interface, they think of things like the buttons or right-click menus and stuff, but you guys are doing some really innovative stuff with some new technology, right?
Yeah, sure. So in 2018, we kind of changed the game a little bit in terms of sketching, trying to work with pen and touch more and get away from picking and clicking icons and commands and get more into just drawing what you want on screen. So the first thing we got back from customers was, hey, I want to be able to do more things. I want to be able to do splines. So we added splines this year, which allows you to kind of create things like the surfboard fin pretty easily. And you just draw that shape, and you get a very nice spline out of it right away. The second most requested thing was slots. So if you're a mechanical engineer, you're probably creating lots of slots and sketches. So now you just kind of sketch that in with a pen. The system recognizes it through Windows Ink, and you get a nice slot geometry in your sketch.
Now that all feels very natural, but one of the things that would feel most natural to me is like just writing down and dimensioning this.
Yeah, well, the other nice thing Windows Ink gives us is handwriting recognition. So now instead of going and changing to the dimension tool and picking some things and typing in a dimension, you just write in the number 3 here, for instance. It recognizes that and adds the dimension for you automatically.
So it really feels like my hands can stay on the screen if I'm on a touch device or a pen, and I don't have to go back and forth between the keyboard.
Yeah, one of our key principles is users are here to create their designs, work on their model, not use our user interface. So this gets them a little bit closer to that, right?
Yeah, so now sketches are a great example of where these things could be used, but what about interacting with the three-dimensional model itself? Have we done anything there?
Yeah, we've actually done quite a bit to make interacting with touch much easier. So we've done some things like moving some of the feedback out of the way of your finger, but also now you can tap things, drag things around on screen. You can see he's doing some adding some mates here. And then also just interacting with the model itself. So tapping on that gear and spinning the whole thing just works with the tap of the finger.
This feels very natural, the way I would want to interact with my three-dimensional models.
Yeah, exactly.
Here.
That's the idea.
Now, another place where it would feel very natural is like the ideation phase or sharing ideas or comments. What about there? Are we doing anything there?
Yeah, so we've added some functions in 3D markup. One of the key things customers tell us all the time that they want to do, or they describe to us is, you know, I take a screenshot, I throw it in PowerPoint, I draw some stuff on it, and then I send it off to, you know, somebody in the shop or a collaborator I need to work with. So we've just added this right into the SOLIDWORKS 3D model. You add a markup view, which are similar to annotation views, and you can just draw on the screen. And that can be saved out to an image format and sent off very easily, and it's stored right there in the SOLIDWORKS file.
Yeah, so likewise, the markup file is going to kind of follow that file around wherever it goes,
too.
Yep,
exactly. It's right there in the SOLIDWORKS model.
I won't lose my napkin.
Exactly.
All right, that sounds good. Kevin, all looks really exciting now. We had mentioned earlier the What's New section of the SOLIDWORKS website just went live. There's lots of new videos there for people to check out. What's something that you're really excited about that people should go watch?
2 quick things. One, recent documents. We took that up to 100. So whether the welcome dialog or the recent documents dialog, you can get a lot more recents there. I think people will be excited about that. Also, we've done a lot of work to the external references dialog. So that's all been revamped, and how you work with it is revamped. And the dynamic reference arrows in the feature manager tree, you can break references, lock them, unlock individually right there in the arrows in the tree. So it should be pretty nice.
Individually is the exciting part for me.
Individually.
Yeah, no, very cool. Kevin, I want to thank you so much for joining us here today, giving people a little bit of a sneak at what they're going to see in SOLIDWORKS 2019. Now, we've covered a lot of stuff today. We looked at performance, some modeling enhancements. We went to IMTS to kind of see how that went with smart manufacturing. We also looked at design to manufacturing and some of the new innovative stuff that we're doing as well. Now, we're not done today, so stay tuned on Facebook and YouTube throughout the course of the day, and we're going to be covering more topics this afternoon. At 1 o'clock Eastern Time, we're going to be looking at mesh to manufacturing, and then again at 2 o'clock Eastern Time, we're going to be looking at some really cool extended reality technology. And then finally, at 3 o'clock this afternoon Eastern Time, we're going to show how to connect the disconnected using some really cool technology available for everybody using SOLIDWORKS. Until then, check out the What's New section of the SOLIDWORKS website and stay tuned till later.